What's going on, guys? This is gonna be for lesson 8, which is part 2 of the loops. Lesson 7 covered part 1. This one's part 2, and it covers more. Yeah, because there's way more to loops than you think. The last time we covered while loops. Just kind of a quick review of what it is. While loops can, well, if you don't have something inside it that tries to break the loop, it will run infinitely forever and it will not end, right? Unless you actually add a break in here. Secondly, you have to put in a wait somewhere in the script, and you could just do wait 1 like that, or you could do somewhere else. But usually the way I recommend that you do it is you do while true do, and then you add a wait somewhere. Okay. But yeah, that's kind of the basic concept for that. Now what we're going to do is we are going to, let me first just comment this. Put like that. I'm gonna do that. Oh, I see why. Okay. I'll put that in there too. Okay. So I think the first thing we're going to go over now is, I'm just going to do repeat loops. I'm going to do this one first. So basically the way our repeat loops work is it will repeat doing the exact same loop until a condition is reached. So basically what it looks like is just you do that, repeat, you hit enter, and then you see an until. And just like before, if you do a while true loop here, you just hit enter there, it's gonna like loop through this really fast and it's gonna crash your studio. And if you do the same like that, it won't work. So you have to define a wait somewhere. So you could do, or a wait 1 right there, like that. And basically, once you have this set up here, you can add the condition right here. So in our case, just for a quick test measure, we're going to do this local value equals 0, right? And we're gonna add value excuse me, sorry. We're gonna add 1 to this value every 1 second. Okay, and the loop is going to break once the value is greater than or equal to 10. So we're just gonna print value right there. Let us hit run. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. Reach this point. So it's very similar to while true do, like what we have going on here. It's the exact same thing pretty much. But the difference is repeat has like a definitive like max condition or like condition that you need to reach, otherwise it'll keep going. While true do's, you can technically just leave it like that and it's gonna run forever unless you add in a break. But yeah, repeat here, it breaks automatically when you can reach your condition that you state. You can do values greater than or equal to 10 and let's say game dot lighting dot brightness equal 2 or something. You know, you can keep going and add multiple conditions. Remember, just like before, all the conditions that you add in, they all have to be equal to true in the end. Otherwise, it's not gonna stop the loop, and you don't want that. When you have a repeat loop, you want it to keep running until you reach some kind of condition. Otherwise, what's the point of using a repeat loop? Okay. So the next is a for loop. There is multiple ways how for loops work. This is probably going to be a part 2 for this loop, actually. It's advanced loops part 2. Yeah. So there's going to be more to specifically for loops. Specifically. So the way how for loops work is, let's put that there, put this there, put this here as well. Okay. So for loops, basically, think of it as it's going to keep counting up to a certain number, and then the loop will stop for this specific type. Okay, so what you want to do is you type in for, and usually people, they do for I equals whatever. I'm just going to type this in just for now. 1 to 10, do. That's it, okay? So what this is doing is every single, okay, basically this whole loop here is going to run 10 times. 10 times, and it's going to start from the number 1, and it's going to count all the way up to 10. So if I just do this real quick, I just add a wait one right there. I just run that there. Okay. So basically, when you're doing for I loops here, the first number here has to be the lowest number. It's the number you're starting from. The second number here is the number you're counting up to. And by default, the third number here will be the increment. So every time we're looping here is going to go up by 1 each time until it reaches 10. You could just leave it like this, and like I said, by default it's going to go up by 1 every time, so you could just leave it like this if you want to, if you're adding up by 1. Or if you want to be technical, you could just slide in the 1 right there and you won't have any issues. Okay, so I'm just gonna try to make a little drawing thing for this. Not a drawing, just little points. So okay, remember, first number is the number you start from. We're starting from 1. Second number is the max number you're going up to, which is 10. The third number is the increment every time. Turn off storage sets. Okay, is the number that you're looping by. Okay. And even here, we could just instantly do, and it's going to count all the way up to 10 instantly because we did not add a wait right there. Okay. Now you could actually experiment with this too now. You can start from a negative number and go up to a positive number. So say we started from negative 10. We're going to count up to positive 10. So it's going to go 20 times at the increment of 1 every time. So we just add this time we're going to add a small weight right there. Counts all the way up from negative 10 up to 10, up to positive 10. And then another trick you can do here is actually you can change the increment. You can make it go up by a positive number, you can make it go down by a negative number, but in this case it's not gonna work. It just won't work because we're starting from a negative number and we're trying to go up to a positive number in the increment of -1. That does not work. So you notice how it doesn't print anything? Because this whole loop right here by default is false. It won't work. It is impossible. But if we reverse this and we do that, now it's going to start from 10, positive 10, and it's going to go down to negative 10 at the increment of negative 1. So it's going to go from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way down to negative 10 in the increment of negative 1. Just like we can see there in the output. Okay. So the ways you can kind of play around with this is, let's see. See, for everything that you're doing, for every single loop here, there's like something going on here, right? Every 1 second with doing the while loop, we change the brick color of the part there to something random. We could do something here where we make the transparency of a part slowly go to 1. Now this is a trick you can use it for too. The basic like for loops have a lot of uses to them, just like other there's like these other loops here. The next for loop that's going to be in the different video, like the intermediate series, is used a lot. This one here is not as used as much, but is very important. So make sure you get that down as soon as possible. So just to remind you guys, the number you were starting from, the number you're going to, and the increment every single time. Okay? So if we're starting from a positive number, we're trying to go down to a negative number. You can't go down to a negative number by going up. But you can go down to a negative number by going down, if you kind of get what I mean. Right? So 1. Right here, this is not going to print anything. That doesn't work. But if we switch this immediately to a positive number right there, that'll work. And you could put any number in here. You could do 0.1 right there, and that still works. It'll still count up right there. Very small increments, but it still works just like that. Okay. Now, you can also use a break loop right here. You can still use a break. Break loop. What the hell? That's not what I meant. You could still implement a break, and this is going to break out of the loop at whatever time you want it to. So, let's say if I is greater than or equal to, if I is greater than or equal to 5, then we're going to warn broke the loop, and then break. There we go. Now let's make sure that is okay. Oh, hit enter, broke the loop. There you go. So remember how I said in loops, they are yields. They will cause everything else to not run unless the loop there is finished or is broken. So by here, we're breaking the loop. So naturally, if I got rid of this and I just left this like that, this whole loop would take 1 second to run, and then it would print reach this point, just like there, just like there, just like there. Broke the loop, reached this point. Oh, whoops. Let me get rid of that. Clear output. Took 1 second to reach this point, or to warn reach this point. Now if I did this, broke the loop, this is going to take half a second. Broke the loop, reach this point. Okay. Now what we're going to do with this, it's a little cool trick. Now, as always, when you guys learn something new, I'll show you a little small way to apply that into the previous lessons that you learned. So what we're going to do now is we are going to slowly make this part right here, delay part in workspace, slowly make its transparency go up to 1 in increments of 0.1. Kind of like that. It's just going to slide slowly like that. Okay. All right. So we're gonna start is from 0 to 1. Notice how that if I do from 0 to 1 in the increment of 1, it's just gonna run this thing one time, pretty much instantly, because it's not running more than one time. But if we do that, it's gonna run multiple times. It's gonna run more than one time. But we're trying to make it go up slowly. We're gonna make it go up every 0.1. Let's just do every 0.2 seconds. We're gonna make delay part right here. We're gonna give this this variable again, delay part dot transparency equals I. Okay. So remember that I is the actual value that's like the number that is kind of representing what's going on here. So if we just run this once, notice how every time when we hit it, it'll print the number that it is and kind of go up from there. So yeah, just gonna do that real quick. Hit run. The transparency slowly went up to 1. And let's add a wait here. So let's add a wait 1 just so we have time to load in the game. And there you go. That is how you can apply some cool changes to that. And then let's change the brick color to something random every time. Whoops. So the brick color is going to be something different every half a second or every fourth of a second, and the transparency is going to slowly go up. And you can even start from 1 all the way to 0. So just like I said, this is going to be starting from 1, going down to 0, going down by -1, -0.1. But in this case, since we're starting from 1, it makes sense if we do this. So what this is going to do is it's going to slowly appear, and that's it. There we go. Now another trick here, if we want to be a little cool with it. This is a little might be a little confusing at first, probably. But let's leave it at this, all right? So we're going to just do this, okay? Leave that like that. Put that back to 0, okay? Now what we're gonna do is every 1 second, we're going to increase this part size by 1 from all dimensions. So it's gonna grow on the x-axis by 1, the y-axis, and the z-axis by 1. So it's basically gonna be growing in a cube, all right? So let's make a little variable for this. So we're gonna do local size equals delay part. We don't even need to do that. We can just put this outside because remember, code is always about efficiency. There's no reason to put this inside here every time and like to find the what do you call it, variable every time. So what we're gonna do is we're gonna get the size of the delay part. It's gonna be that. That is gonna return a vector3 value. Remember how I told you guys, this vectors are basically, there's 3 axes. There is x, y, and z. Remember that the red one here is x. So if I was to do this to make it like a size, like a part size this, it would look like this. Be 10 on all dimensions. Now this properties here gets kind of confusing, so best of luck getting through that. Won't be too difficult, but here you go. Kind of get the gist. You know what I mean? Alright. So, and for every like vector3 value you get here, there's going to be something. There's going to be like, you can get the specific axes of the vector just by merely typing size dot size.x or size.z or size.y. Okay? So just for test purposes, what we're going to do is we're just going to merely print out the x-axis size of this part right here, which is 6. So let's do print size.x. Oh, I see what I did wrong. There we go. Print 6. There you go. And yeah, all right. So what we're gonna do is we're gonna make it grow every time. So we do delay part. Whoops. Delay part dot size equals vector3 dot new. Now we're gonna do size dot x plus I. We're gonna do size dot y plus I and size dot z plus I. Okay, so if just like I told you guys before, what vectors, like, how do I explain this? Like the axis inside of vector 3, I told you guys which one represents what. So this one here, the first argument here is the x-axis, which is why we're getting the size.x, and then we're adding 1 to it. Then we're getting the size.1, size.i. And we're going to add I to it as well, and then so on and so forth. So if we just do this, slowly but surely, it is increasing in size by 1 every single time. Alright. Hopefully you guys understood what I did through this video. Yeah. I'll see you guys later. Good luck scripting.